Hi, Algebra 2. This is picking up the videos that was having trouble in class. So we're looking at note set 5 on transformations for Monday. And I think we went over our parent function and we said we have the points 0, 0, 1, 1, negative 2, 2. We also commented that we know that things inside the function changes our x's. Things outside change our y's. And so what I believe that we've already talked about was that the x minus 1, remember x's lie to you, that goes right 1. This negative 2 out front is being multiplied, so I actually wrote down we multiply y by negative 2, but that has two descriptions to it. It's a reflection over your x and a vertical stretch by 2. And then this plus 2 on the end takes your graph up 2. So I'm going to take my parent function. I'm simply just going to do what this list tells me. I like to start in this one with 0, 0. So I'm going to move it right 1. Multiply my y value by negative 2. Well, currently that y value is 0. So 0 times negative 2 is still 0, up 2. So that new point is 1, 2. Okay, let's take 1, 1. So I'm going to, again, go right 1. Multiply my y value by 2. Right now my y value is 1. 1 times, negative 2 is negative 2. And then up 2. So I'm seeing the point 2, 0. I need one more point on this parent function. And you guys told me in class to use negative 2, 2, which is certainly fine. Go right 1. Multiply my y value by negative 2. Right now that y value is 2. 2 times negative 2 is negative 4. And then up 2. So we're at the point negative 1, negative 2. And there's my graph. Okay. As I look at this next one inside my phone, I forgot one thing. Write it as a function of f of x. And so g of x will equal, again, and g of x is just this statement, negative 2 times our parent function, x minus 1 plus 2. Okay, let's go to B part. Let's actually on B part write it as a function of f of x first. So we see that we're multiplying the function by 1/3. Inside my function is x plus 1, and then on the end I will have minus 1. Anything inside the function changes your x values, and x's lie to you, so this is going to be going left 1. The 1/3 and the negative 1 both change y's. And so the 1/3 is multiplying y by 1/3. And you do multiply before you do the subtraction, so order will matter. If you multiply by 1/3, numbers are getting smaller, so that's a vertical compression by 1/3. And then you're going to go down 1. So I'm going to start at 0, 0, go left 1. Multiply the y by 1/3. That will not change. And then down 1. So I get negative 1, negative 1. Now, I'm going to go back and look at this parent function creatively. If I know that I'm going to need to multiply the y value by 1/3, what point would be convenient to use? What's something that I can see on this parent function that is going to be a nice, pretty y value to multiply by 1/3? Hopefully you said 3, 3. 3, 3 is on my parent function. So I'm just going to go down this list of transformations. Go left 1. Multiply your y value by 1/3. Well, right now my y value is 3. 3 times 1/3 is 1. And then down 1. That point is now to 0. On the other hand, I also see that negative 3, 3 is on this graph. And again, I'm choosing a nice pretty point to multiply by 1/3. So I'm going to take negative 3, 3 and go left 1. Multiply the y value by 1/3. 3 times 1/3 is 1. And then down 1. So I see I get negative 4, 0. And there's that function. All right, let's turn the page here. Ooh, so now we've got a new parent function. So it looks like we've got 0, 0, 1, 1, 4, 2, 3, 9. This time, the 2x and the plus 2 are both inside this square root function. So they both change x's. Now here's something you have to be really careful about. Even though these both change x's, in order to translate, I have to factor this 2 out. Anything in front of the x has to have a coefficient of 1. So I'll have the square root of 2, and then what's left over will be x. And if I pull 2 out of 2, I'm left with x plus 1. Now, as a reminder, x's lie to you. So even though this is 2, I'm really going to multiply my x's by 1/2. And so I like to put that in parentheses. Multiply x by 1/2. If I multiply by 1/2, that's horizontal since it's x's. If I multiply by 1/2, numbers get smaller, so it's a compression by 1/2. And then I will go left 1. And yes, order does matter there. I have to multiply before I add or subtract. And there is no y movement here. So let's take 0, 0. If I multiply 0 by 1/2, it doesn't change. Go left 1. So that new point is -1, 0. I can choose any of these parent function points that I see up here, but I want to choose something convenient. So let's choose 4, 2. Now, why would I choose 4, 2 from the parent? Well, what happens when I take the x value of 4 and multiply it by 1/2? 4 times 1/2 is 2. That's nice and pretty. And then left 1. Like I said, nice and pretty. That point became 1, 2. We can go ahead and do the point 9, 3 if we want to. Take 9 and multiply that by 1/2. I get 9 over 2, which is 4.5. So my pencil's at 4.5. And then left 1. So that point becomes 3.52. Notice the y value did not change. If I want to write g of x as a function of f of x, both the 2x and the plus 2 are inside the function, or if I wanted to, I could certainly write that as it being factored. Either way would be a correct answer. Okay, let's look at B part here. So B part, notice the only thing I have changing the x's is this 1/2, and then the plus 3 is changing the y's. Remember, x lies to you, so you're not actually going to multiply your x by 1/2. You're going to multiply x by 2. Since you're multiplying x's, that's horizontal. If you multiply by 2, things are getting bigger, so that's a stretch by 2. And then last, I've got that plus 3. That's up 3. That's up 3. So I'm going to take the point 0, 0, and I'm just going to go down my list. Multiply my x by 2. Well, 0 times 2 is still 0. So I just need to go up 3. 1, 2, 3. That point is 0, 3. 1, 1 is a point on my parent function I see up above. I'm going to multiply that x value by 2. So currently my x value is 1. 1 times 2 is 2. And then up 3. 1, 2, 3. Okay, going back to the top of the page and looking at my parent function, I have the point 4, 2. I take that x value of 4. 4 times 2 is 8. And then I move up 3. 1, 2, 3. That ordered pair is now 8, 5. And there we go. So if I want to write that as a function, I would say f of 1/2 x and then plus 3. All right, let's see. Let's do new parent function here. Parent function's a parabola. Actually, I'm going to skip this. I'm going to turn back here to this next page. So I want you to notice it's the same parent function we were dealing with just a second ago. So as I look at 4a, I see that I have a -2 under my x's, so those change x's. I have a y movement and a y movement. So let's talk about the x's for just a second. So even though this is a -2, remember x's lie to you. So I'm going to multiply x by a -1/2. Now, multiplying x's by a negative is actually a reflection over your y-axis. It'll take your graph and it'll reflect it like this. It's over your y-axis. And then the 1/2, these are actually on the same step, that's why I'm writing them beside each other. Since I'm multiplying x's, that's horizontal. If I multiply by 1/2, things get smaller, so that's a compression by 1/2. And I can take care of those both at the same time by simply multiplying by a negative 1/2. I have no other x movement. For my y's, I can multiply y by 3, which is a vertical stretch by 3, and then I'm going down 1. And order will matter there. I have to multiply, whoops, you couldn't see that. I have to multiply my y's before I go down 1. So I'm going to take my parent function and simply go down this list. So I start with 0, 0, multiply the x by negative 1/2. Well, that x value is 0, it won't change. Multiply the y by 3, again, that y value is 0, it won't change. Go down 1. 1, 1 is on my parent function. Multiply the x's by a negative 1/2. Right now, that x is 1. 1 times negative 1/2 is negative 1/2. Take the y value and multiply it by 3, so its y value is 1. 1 times 3 is 3, and then go down 1. So I'm getting the ordered pair there, negative 1/2, 2. Okay, let's take 4, 2. That's on my parent function. Multiply my x value by a negative 1/2. Currently, that x value of 4, 2 is at 4. 4 times negative 1/2 is negative 2. Multiply my y by 3. My y value is 2. 2 times 3 gives me 6. And then down 1. So I'm getting the point negative 2, 5. So as you look at that, we can see that it was compressed horizontally. It did reflect over the y. It was stretched vertically. If you can see my hands, it was stretched vertically and did go down 1. And then we can write this as a function. So it would be 3 f of negative 2x and then minus 1. And then I may put up a video that has a couple of the other problems in it with factoring. But for right now, I'm getting ready to start class. That's what I have time to do. So see if there's another one here.